Hey guys, let's pick up where we left off, see how far we get in this next video. The last video I was working on solving quadratics using things like the quadratic formula in factoring. Here we're going to use another method for square roots. I can use that with vertex form and standard form if there's no just plain x, if it's just an x squared. Anyway, so for this problem, what I'll need to do is isolate the square part, like get the square part alone. So you're just going to do some algebra 1 to make that happen. And so I'm going to have 2 still sitting out in front here. And then I'll need to divide that 2 out. So at that point, I have the squared part equals 19. And then to get rid of it, I introduce the square root, but you do have to bring in that plus or minus. On this side, it just cancels. And I have either positive or negative square root 19. 19 doesn't contain any perfect squares. I still need to take away 4, and I really can't take it away from that. So I end up with a negative 4 and then a plus or minus the square root of 19 as my exact answer. So that'll be tricky if you're relying on your calculator because it won't give your answer in that method. So make sure that you kind of understand how to do these without just getting a decimal. Here we started to talk about I, and I, if you recall, is the square root of a negative. And I squared is negative 1. Those are the 2 key elements. So if you have a square root under you have a negative under your square root sign, you should have an I in your answer. So for example, here I would think of this as the square root of 16 and the square root of negative 1. This comes out as 4, this comes out as I, and my answer is 4I. Here I'm going to split it up like I did before and say, hey, 9 goes into 18 and is a perfect square times 2 times negative 1. So this comes out as a 3, this comes out as an I, and the square root of 2 is the only thing left in there. Here I'm going to distribute because when you see that, you kind of know that's what you're going to do. So I'm going to multiply that and get 6I, and over here I'm going to get 8I squared, but I squared should never be in your answer because it has a value of negative 1. And so I end up with this, but standard form puts the real part and then in front of the imaginary part. So I'm going to have my negative 8 and then plus 6I because the 6I was positive. Here, when you see this, you know you're going to need to FOIL. So first, outside, inside, and then last. But again, when you're doing that, this one's going to end up having an I squared, which is a negative 1, and turning it into a positive 5, which is then just a regular number and can combine with the 2 to give you 7. And these two are alike, so you're going to get negative 3I. I always say treat I like x until it's squared, because once it's squared, you're just going to have to go ahead and make it a negative 1. But like here, if you had negative 5x plus 2x, you just put them together. Now, you can't have a square root on the bottom, and since I represents a square root, we got to get rid of that. So we use what's called the conjugate, and the conjugate is changing the sign of the I part. So here on the top, I just get negative 6I, but on the bottom, I get negative 4I squared. But negative 4I squared is negative 4 times a negative 1. So I ultimately end up with negative 6I over 4, which reduces to negative 3I over 2. So that takes a lot of like little steps and paying attention to details. So watch for that. Here I'll need to take the conjugate as well. And it will be, again, just the opposite of the I part. So 2 minus I. Here I just need to distribute 6 minus 3I. But on the bottom, I'm going to FOIL, and it should turn into a regular number. So 2 times 2, the outside is negative 2I, but the inside is positive 2I, and that should always happen that those cancel. And then the last is a negative I squared, and that should always happen that you end up with a real number. So in the end, I have my 6 minus 3I on the top, and 4 over here plus 1 gives me a 5 on the bottom. And then you can separate it, because then technically you have your real part minus, in this case, your imaginary part. So on the test, it'll be multiple choice, and you'll have to be able to match to however the answer is written. All right, now we're going to solve again, which means get that x alone, but it is telling us we might get imaginary answers. So 2x squared plus 1. I start with some algebra 1 and I take that away. Be careful that stays negative and goes to negative 8. Dividing by 2, I have that x squared equals negative 4. So when I bring this in, I end up with plus or minus the square root of negative 4. Well, that's going to be a 2, but also an I because of the negative under there. So my answer is going to be choice C. Same process here, except I don't have as many steps. I'm just going to divide by a negative. I end up with x squared equals negative 9. So when I go to do my square root here, x is going to equal plus or minus the square root of 9. And that's going to be a 3 and then the I because of that negative underneath there. So I end up with choice B. All right, now we're into chapter 5. So the thing to do is go to your notes packet, anything you have from chapter 5 to help you. This is the rules of exponents, and this is really tricky because there's a lot of picky details. When you have a power on the outside, you multiply it by all the powers on the inside. Powers and numbers don't multiply, so this becomes 3 to the negative third power. They don't multiply together. X to the negative 3, 5 to the negative 3, and then this x is actually to the negative 6. Anything with a negative power has to move. So in this case, everything on the top is moving to the bottom to become a positive power, and everything on the bottom has to move to the top. Then you can, with the number part, figure out the numbers. So 5 to the third, and we had a power chart to help you with that. And then 3 to the third, and that actually does not reduce, so it's just going to stay like that. And then with this, the difference between 6 and 3 is 3, and the extras would end up on top because this is really 1, 2, 3, 4, 5, 6 of these over 3 of them. So 3 of them cancel, and those extra 3 are left on the top. So it's subtraction, but it's just kind of like thinking about wherever you started with the most, that's where they'll stay. Here, just this is negative, so it'll have to go to the bottom, and just this power is positive, so negative, so it'll have to go to the top. So the 2 and the y to the fifth will be up there, but this y to the second will join them. On the bottom, I have my 16 and my x to the third, but that x to the sixth will move down there and join them. Then anytime you have these neighbors that are the same power or the same base, you can go ahead and add their powers because this is saying I have 5 y's, I have 2 y's. So you have 7 y's total. Here you have 3 and 6, so that's 9 x's. And then the only thing you need to do is reduce that since they both divide by 2. So I end up with 1 y to the 7th over 8x to the 9. Here I would probably distribute the 3 first. I'll let these guys sit around. Later on, they can multiply with the neighbors. But for right now, this becomes 5 to the third, x to the negative third, and y to the third. Then this is the only one in the problem that has to move to the bottom because it has a negative power. So I'm going to have a 2, an x, a 125. These are all getting multiplied on the top. And then I'm going to have a 4, a y to the third, and the x to the third that I just brought down there. So on the top, I end up with 250 for a number part. And on the bottom, and then an x. And on the bottom, I end up with 4, y to the 4 because these combine. And then x to the third. So if I reduce my number part, they both divide in half to be 125 over 2. Then here for x's, I have 2 extras, but they're on the bottom. And then my y to the 4 doesn't have anything else to interact with, so I end up with a y to the 4 on the bottom. All right. Here, we're getting into more of the function notation. All this means is that everywhere there was an x, in here, you're going to plug in a negative 3. So this becomes a calculator thing. I'm going to plug my negative 3 in. I'm going to be careful of using parentheses when it's a negative. And then put that whole thing into my calculator. And that will kick out a 42. Same thing here. I'm putting in a negative 1. So anywhere there was an x, I'm putting in a negative 1. If you forget the parentheses, it will give you the wrong answer because it doesn't realize that you're squaring the negative along with it. This one comes out to actually be 0, and so your answer is B. Subtracting is tricky because it's like having a -1 that distributes, so be really careful. This is one of the easiest things to get wrong. So you got to switch all those signs after, and then you're just combining like terms. So here I have a 3x squared. Oops, those are not alike. Actually, they are. Why did I write it next to fifth? I must have been looking at that 5. So I have a 3x squared and a minus 7x squared, which will go together to be a -4x squared. Here I have a 5x and another 5x, so they go together to be 10x, and then a -2 minus 4 more is -6. Adding is easier because you don't have to worry about switching signs, so this 2x squared and this 8x squared goes right into being a 10x squared. A 3 plus a 3 is 6x, and a 7 minus 4 is a +3. So it's really just combining like terms. It's the minus that you have to be careful of. Here there's no symbol in between, which means I'm going to need to multiply. I'm going to distribute the x to everything. That's going to give me an x cubed plus 6x squared minus 11x. Then I'm going to distribute the 4 to everything, and I line them up. So like when I get 4x squared, I put it under the other x squared. 4 times 6x is 24x. 4 times -11 minus 44. Then I can combine my like terms easier than if I have them in a big long row. So if I do that, I'm going to have an x cubed. Here I'm going to get a 10x squared. Here I'm going to get a 13x because one of them's negative. And then I have my minus 44. This one's straight up FOIL. So I'm going to do my first terms, my outside, my inside, and my last. These can combine, so my final answer is 2x squared plus 2x minus 12. This one is only one item out in front, so I'll just distribute it. So we actually started off with a pretty hard one and worked towards ones that we're more familiar with. I end up with 2x cubed minus 5x squared and a minus 7x. And then this one's back to double distributing. I have to multiply everything by 5x squared. So I'll get 10x to the 4. Here I'll get 5x to the 3rd and minus 15x squared. When I go to multiply these, I get a 4x squared plus 2x minus 6. So the only common term they have is right here as an x squared term. And so my answer for 75 is 10x to the 4 plus 5x to the 3rd minus 11x to the 2nd plus 2x minus 6. And so throw that on the answer line. Okay, so back to solving. This one doesn't tell me what to do. So I would try factoring. I would need 18 in a way that subtracts to be 3. So I would pick 3 and 6. And then I would say, well, I need it to be a positive 3. So I would need plus 6 minus 3 to make that happen. And then for them to be 0, I solve each one for like what would make it 0. Here it would be -6. Here it would be positive 3. So 3 and -6. So my answer for that is B. This one tells me to factor, but this one's tricky because it's got a number in front. And so I'm going to show you again how I do that. You don't have to do it my way, but I put a 3x here and here. 3 times 8 is 24. And then I look at my card to see all my options for 24. But I need one that subtracts to be 23. So actually this first one is the right one. To get a -23, I'll need a -24 plus 1. This doesn't reduce by anything, but here I could divide out a 3. So my factors turn out to be these two. And then I'm solving. I'm trying to get what makes that 0. So I'll need to find out what makes this 0. I'll have to subtract over the 1 and divide by 3. And then in this one, to find out what equals 0, makes that equal 0, I simply add the 8 to the other side. So I'm looking for a negative 1/3 and then also an 8. This one is really complicated looking, and so I'm going to remember that I want to do GCF because you got to check first. That's always the first thing. So if you feel stumped, that's probably what it is. So I'm going to find something that goes into both of these, like the biggest thing, and that's going to be a 6 and then an x to the third, because I can't take more x's out than 3 because the second term only has 3 to give. What's left here would only be an x to the second. And then what's left here is just a 9 because all 3 x's cancel. Okay, well then this has a second layer because that is done, but this is the difference of 2 squares. That's the square of x, that's the square of 3. So it breaks down further into x plus 3x minus 3. So now to get my zeros, I look at what makes this 0. Well, that'll only equal 0 if x is 0. This will only equal 0 if x is negative 3. And this last one will only equal 0 if x is positive 3. So my answer is going to be 0, 3, and 3. So that is choice D. Same thing here. It looks kind of confusing, so I'm going to take out anything that I can. And in this case, both of them can divide by 7. And the most x's I can take out is 4 before this second term runs out. So I take that 7x4 out front. Here, all I have left is an x squared. Here, I have a 4, and then these are gone. Same exact setup, which tells me there's probably one like that on the test, because this is a perfect square of x. This is the perfect square of 2. So I have the difference of 2 squares. The sum and the difference makes my factors. Now I need to solve. So again, the only way for this to be 0 is if x is 0. The only way for this factor to be 0 is if x is negative 2. And then the only way for this to be 0 is if x is positive 2. So I get 0 and then also plus or minus 2. All right, new concept, my friends. This is going to be where you have to find the relative minimum. That's going to be an XY point that's like a valley. So that's this right here. She has them backwards on the answer key, just so you know. So the lowest it goes is 0, negative 6. 1, 2, 3, 4, 5, 6. And then I just wrote it in the wrong spot after looking at the answer key, sorry. And then the relative maximum is going to be a high point, like a peak, that is also just an XY point, and that's at negative 2, negative 1. So those are my max and mins. Now, increasing and decreasing is just an eyeball activity. Increasing is where is it going up from left to right, and then decreasing is where is it coming down. So this is going to be going up from left to right here and here. And you describe it using x's. So this goes forever. So you can describe this 2 different ways. You can say from negative infinity, which would be over here, to wherever it stops, which is at negative 2, because you're only ever using x's to describe intervals. And then it starts to increase again here, which is at 0 as an x, on to forever. So you would write this if you wanted to as x is less than negative 2, not or equals 2 really, because it's not decreasing or increasing. And then here you'd say for x is greater than 0, but you have to be able to match that because it'll be multiple choice. So make sure you understand both ways. Decreasing is from here down. And again, you're only using the x's. So that's from the x here at negative 2 to the x at 0. And so if you were to write it the other way, you'd have to write it like this. But again, with multiple choice, you have to know both ways so that you can recognize it. End behavior is what the right and left ends are doing. So just a quick refresher, the right end is over here, but that's x going to infinity. The left end is over here, but x would be going towards negative infinity. If you think that something's going up, that's going to be going towards positive infinity as a y, and here y's are going towards negative infinity if the graph is going down. So we learned to look at the degree, which is even in this case. Even means they'll be the same ends, so both going up or both going down. Then we look at the leading coefficient and say, well, that's negative, which means the right end is going down because the leading coefficient tells you what the right end is doing. So if my right end is going down, but they're doing the same thing, my left end is going down also. So up here, where it's asking what happens as x goes to negative infinity, well, that's the left end. Since it's going down, I would write negative infinity. X going to positive infinity is over here. They're asking me what's the right end doing. And since it's going down also, I would also put negative infinity. My choices are just positive or negative infinity. In this second example, my degree is 3, which is odd. And that tells me that they're going to be the opposite. They're going to do the opposite thing. My leading coefficient is positive, so the right end's going up, but since the left end is doing the opposite, it will be going down. So this left end is going down, negative infinity. This right end is going up, so positive infinity. All right. I think I'm going to stop the video now, and then I'll make another one for the last unit, for unit